So in this class, let us solve exercise 1.6 of sets chapter. First question, if x and y are two sets such that n of x is equals to 17, n of y is equals to 23 and n of x union y is equals to 38, find n of x intersection y. So let us solve this problem. Solution. So they have given there are two sets x and y and number of elements in set x is 17. So given n of x is equals to 17. Number of elements in set y is 23. N of y is equals to 23. And n of x union y is 38. That is number of elements in x or y is equals to 38. So we have to find number of elements in x intersection y. So that is we have to find the common elements in the set x and y. So let us use the standard formula. We know that n of x union y is equals to n of x plus n of y minus n of x intersection y. So number of elements in x or y is equals to number of elements in x plus number of elements in y minus number of elements in x and y. So let us substitute the given values. N of x union y means that is 38 is equals to number of elements in set x is 17 plus number of elements in set y is 23 minus n of x intersection y. So that is 38 is equals to 17 plus 23, that is 40 minus n of x intersection y. I'll take 40 to LHS. 38 minus 40 is equals to minus of n of x intersection y. 38 minus 40, that is minus 2 is equals to minus of n of x intersection y. So we can cancel minus on both sides. So n of x intersection y is equals to 2. So that is common elements in the set x as well as y is 2. Second question, if x and y are two sets such that x union y has 18 elements, x has 8 elements and y has 15 elements, how many elements does x intersection y have? Solution. So they have given x union y has 18 elements, that is number of elements in x union y is equals to 18 and number of elements in x is 8. N of x is equals to 8. Y has 15 elements. N of y is equals to 15. So we have to find number of elements in x intersection y. So we have to find n of x intersection y. So let us use the standard formula. We know that n of x union y is equals to n of x plus n of y minus n of x intersection y. So now substitute the given values. N of x union y, it is given n of x union y is equals to 18 is equals to n of x, number of elements in set x is 8, plus number of elements in set y, that is 15, minus we have to compute n of x intersection y. So I will write as it is. So that is 18 is equals to 15 plus 8, that is 23, minus n of x intersection y. So take 23 to LHS. So 18 minus 23 is equals to minus of n of x intersection y. So 18 minus 23 means minus 5 is equals to minus of n of x intersection y. So if we cancel minus on both sides, so we get n of x intersection y is equals to 5. So the common elements in the set x and y is 5. Third question. In a group of 400 people, 250 can speak Hindi and 200 can speak English. How many people can speak both Hindi and English? So we have to find number of people who can speak both the languages, that is Hindi and English. Solution. So we are going to represent Hindi by H and English by E. So what is given? There are total 400 people. So n of H union E is equals to 400. And 250 can speak Hindi. That is n of H is equals to 250, and 200 can speak English. So n of E is equals to 200. So we have to find number of people who can speak both Hindi and English. So we have to compute n of H intersection E. So again we can use the standard formula. We know that n of H union E, that is number of people who can speak Hindi or English, is equals to n of H plus n of E minus n of H intersection E. Now let us substitute the given values. So they are given, there are total 400 people. So n of H union E is equals to 400. That is equals to n of H. N of H means 250 plus n of E. N of E is 200 minus n of H intersection E, or 400 is equals to 250 plus 200. 250 plus 200 becomes 450 minus n of H intersection E. Now take 450 to LHS. That is 400 minus 450 is equals to minus of n of H intersection E, or 400 minus 450, that is minus 50, is equals to minus of n of H intersection E. We can cancel minus on both sides. So n of H intersection E is equals to 50. So that is number of people who can speak both Hindi and English is equals to 50. Fourth question. If S and T are two sets such that S has 21 elements, so it is given set S has 21 elements and T has 32 elements, and S intersection T has 11 elements. So 11 elements are common for the sets S and T. So we have to find how many elements does S intersection T have. Solution. So they have given S has 21 elements. So number of elements in the set S is equals to 21. T has 32 elements. Number of elements in T is equals to 32. S intersection T has 11 elements. So n of S intersection T is equals to 11. So what we have to compute here, we have to find number of elements in S union T. So again, let us use the standard formula. So we know that n of S union T is equals to n of S plus n of T minus n of S intersection T. Now substitute the given values. So n of S union T is equals to n of S means 21 plus n of T is 32 minus n of S intersection T, that is 11. So that is equals to, so here 21 plus 32 minus 11. So what we will get 21. Here if we simplify again 21. So that is 42. So number of elements in S union T is 42. Fifth question. If X and Y are two sets such that X has 40 elements, X union Y has 60 elements, and X intersection Y has 10 elements, how many elements does Y have? So first let us write the given data. So there are two sets X and Y. X has 40 elements. So number of elements in the set X is equals to 40. X union Y has 60 elements. So number of elements in X union Y is equals to 60. X intersection Y has 10 elements. Number of elements in the set X intersection Y is 10. So that is common elements is 10. So we have to find the number of elements in the set Y. So we have to find number of elements in the set Y. So let us use the standard formula. So we know that n of X union Y is equals to, So that is number of elements in X or Y is equals to n of X plus number of elements in Y minus n of X intersection Y. So now substitute the given values here. N of X union Y, that is 60, is equals to n of X means 40 plus n of Y. So n of Y we have to compute, so that is n of Y minus n of X intersection Y, so that is 10. 60 is equals to here 40 minus 10, that is 30 plus n of Y. So take 30 to LHS, that is 60 minus 30 is equals to n of Y, or simplifying 60 minus 30 becomes 30 is equals to n of Y. So number of elements in the set Y is 30. Sixth question. In a group of 70 people, 37 like coffee, 52 like tea, and each person likes at least one of the two drinks. How many people like both coffee and tea? Solution. So there are total 70 people, and it is given that at least one of two drinks. Each person likes at least one of the two drinks. Suppose if I represent coffee by C and tea by capital letter T. So what I can write here, n of C union T. So that is number of people who will like either coffee or tea, means at least one of the two drinks is 70. Also 37 like coffee, so n of C is equals to 37, and 52 like tea, so number of people who like tea is 52. So what we have to find here, we have to find number of people who like both coffee and tea. That is, we have to find n of C intersection T. That is, number of people who like coffee and tea. We know that we are going to use the standard formula. N of C union T is equals to n of C plus n of T minus n of C intersection T. So that is, number of people who like coffee or tea is equals to number of people who like coffee plus number of people who likes tea minus number of people who like both coffee and tea. So let us substitute the given data. So n of C union T, that is 70, is equals to n of C. N of C means 37 plus n of T. N of T is 52 minus n of C intersection T, which we have to compute. Or 70 is equals to 37 plus 52, that is 89, minus n of C intersection T. So take 89 to LHS. 70 minus 89 is equals to minus of n of C intersection T. So 70 minus 89 becomes minus 19 is equals to minus of n of c intersection t. So if we cancel minus on both sides, so what we'll get? We get n of c intersection t is equals to 19. So that is number of people who like both coffee and tea is equals to 19. Seventh question. In a group of 65 people, 40 like cricket, 10 like both cricket and tennis. How many like tennis only and not cricket? How many like tennis? So there are total 65 people. So among 65 people, 40 like cricket and 10 like both cricket and tennis. So solution. So let C represents the cricket and T represents tennis. So it is given group of 65 people. So that is n of C union T. So number of people who like either cricket or tennis is 65. Again 40 like cricket. That is number of people who like cricket is equals to 40. 10 like both cricket and tennis. So number of people who like both cricket and tennis is 10. So we have to compute how many like tennis as well as how many like tennis only and not cricket. So first let us compute how many like tennis. So if we use the standard formula, so we know that n of C union T is equals to n of C plus n of T minus n of C intersection T. Substituting the given data, so here n of C union T means 65 is equals to n of C, number of people who like cricket is 40. So n of T we have to compute minus n of C intersection T. So number of people who like both cricket and tennis is 10. Or 65 is equals to 40 minus 10, that is 30 plus n of t. So take 30 to LHS. 65 minus 30 is equals to n of t. 65 minus 30 becomes 35 is equals to n of t. So number of people who like tennis is how much? 35. So next we have to find number of people who like tennis only and not cricket. So let us compute number of people who like only tennis. So number of people who like only tennis, see here, number of people who like tennis is 35. It means what? The people who like tennis, again there are some people who like both tennis and cricket. So number of people who like only tennis, what we can write? Number of people who like tennis minus number of people who like both cricket and tennis. So that is equals to, so already we got number of people who like tennis is 35 and it is given there are 10 people who like both cricket and tennis. So simplifying, what we will get? 35 minus 10, that is 25. So number of people who like only tennis is 25. So question number 8. In a committee, 50 people can speak French, 20 speak Spanish, and 10 speak both Spanish and French. How many speak at least one of these two languages? Solution. So let us S denotes Spanish, F denotes French. So it is given 50 people speak French. So number of people who speak French is equals to 50. And 20 speak Spanish. So number of people who speak Spanish is equals to 20. Also, it is given that 10 speak both Spanish and French. That is N of S intersection F is equals to 10. So what we have to find here? We have to find number of people who speak at least one of these two languages. So that is, we have to find what? N of F union S. N of F union S means number of people who speak French or Spanish or both. Okay. So directly we can use the formula. So if you use the standard formula, N of F union S is equals to N of F plus N of S minus N of S intersection F. So substitute the given values. N of F, that is number of people who speak French, is 50, plus N of S, number of people who speak Spanish, is 20, minus number of people who speak both French and Spanish, that is 10. So if we simplify, what we'll get? 50 plus 20, 70 minus 10, that is 60. So number of people who speak at least one of the two languages, that is Spanish or French, is 60. So this is the end of exercise 1.6. Thank you.